Hello and welcome to Chemistry 101, Quantum Numbers. Today we're going to be talking about quantum numbers. And what is a quantum number? Well, here we go. There are 4 letters that pertain to the quantum numbers, or which each letter represents a number. You have principal quantum number, which is represented by N, and describes the size of orbital. You have the angular quantum number represented by the L, which describes the shape of the orbital. The magnetic quantum number, which is represented by M, describes the orientation in space. The reason why it's called magnetic quantum is because it's first observed in a magnetic field, so it head on. And then the spin, represented by the S, tells you the spin. So let's go ahead and jump in right into it. An orbital diagram for oxygen, and then we are given down here the right next to it the electron configuration of oxygen, because that's what you need in order to draw an orbital diagram. Alright, and an important thing to know when you draw orbital diagrams is that the S box there will only be one box. There will be 3 boxes for P, 5 boxes for D, and 7 boxes for F. Well, an easy way to remember this is that when you are given when you have your electron configurations, S only has 2, the maximum of 2. So and then you'll divide by 2 to get 1. That's 1 box. There's a total of 6 P's in a electron configuration. 6 divided by 2 is 3. There's 10 D's. 10 divided by 2 is 5. 14 F's. 14 divided by 2 is 7. So that's how you can remember it. Alright, so let's draw a orbital diagram of oxygen. So we're going to start by putting 1s there. Alright, and there's no p's that go with 1s, because there's no 1 p's, there's only 1s squared. So then we're going to put our 2s here, put our box here, but there is a 2p. So remember, there are 3 boxes, 4 p's. This would be considered 2p. Alright, we're not done here yet. The atomic number of oxygen is 8. So we must fill this correctly. There should be 8 arrows. In order to do this, you go up and you go down. Or you can go down and up, doesn't matter, but they have to be opposite of each other. And you go from left to right. Left to right. But since there's only 1 box, and there's multiple boxes up here, this has to be filled. And then you go left, and then you go up, up, down. This one has to be filled because there's multiple boxes to the right of it. Now, this is where people might mess up. You go up, you go up. Now, we have reached 2, 4, 5, 6. So there's 7, 8 still left. So let's keep going. There, and then there. So 2, 4, 6, 8. So we have reached the maximum electrons in this. Now, it's important to remember, whenever you have multiple boxes, such as in P, the sublevels P, D, and F, you must go 1 and then go over 1 over 1. And once these are filled, see how 1 arrow is in each one. Once those are filled, you come back and do the down arrows. Important to remember. So this is our orbital diagram of oxygen. Now, how does this pertain to the quantum number? Well, this is very important to determine your the letters M and the letters S. So let's talk about what these letters mean up here. So your N, let's see how to find them, shall we say. So your letter N is your period number. And say we're still going to use the example of oxygen in this case. So the period number. Alright. So our N is going to equal, well, if we look at a periodic table, the row number is 2. The period number is 2. So that is going to be 2. Now, if we come up and we look at our angular quantum number, or our L, this describes the shape. The L, the shape, that is determined by the sublevel. What's a sublevel? Remember, it's just easy S, P, D, or F. So that looks like an E. And each one has a number. S is 0, P is 1, D is 2, F is 3. So, in this case, if we look at our periodic table, and if we look where oxygen is, we know this in our, we will look at our final electron configuration, and we notice that it is 2p4, p meaning that's the sublevel it ends at, so p, so the sublevel is p, so that would be 1. Alright, then we're going to go to our M, our magnetic quantum. There's no simple way like these to find your number, but you must use the orbital diagram. How? Well, the M can be negative. M can be -3, -2, -1, 0, 1, 2, 3, etc. But to actually determine it, to determine our M, the middle will always be 0. And then to the left of it, it's going to be a negative. To the right, it's going to be a positive 1. So, in order to determine what the M is, it's where the last electron goes. So we went up, over, down. And this is our last electron. So, our M is going to be -1. And then we come to our spin. Our spin determines if we are full or not. We are not full, so this is going to be a positive 1/2. If there was arrows here, it would be -1/2. You would think that negative meaning you're missing, but no, just think the opposite of that. So our spin is going to be, for this, it's going to be positive 1/2. So this is how you determine quantum numbers. It's very important for chemistry to determine electrons in an element. But this is how you do it.